Morning children, I hope you had completed your group 15 and the group 16 elements. Presently we are having only synopsis and very important bits from this group 17 elements. So you had already read the textbook, I hope. What are the group 17 elements we have? We have the group 17 elements of fluorine, chlorine, bromine, iodine, acetylene and tennessine. Tennessine is the radioactive element, that's of atomic number 170. Atomic number of 170. What are the atomic numbers of these elements, children? Fluorine 9, chlorine 17, 50, 35, 53 and the 85. Here tennessine is already we have seen 170. What is the general electronic configuration of this group? General electronic configuration of this group is NS2 NP5. So before this we will have the noble gas, because this data is also asked in some objective examinations. I need not want to introduce about the occurrence. In the occurrence, you don't forget about the source or the compound formula they will give. You can see the fluorspar. Fluorspar is the combination of calcium fluoride, cryolite, Na3, Al, F6, Na3, Al, F6, fluoroapatite. Apatite family we had already introduced in the last class. Ca3, PO4 twice. Here 3 moles we can take. Fluoroapatite, calcium, fluoroapatite, this one fluoride regarding. Whereas carnallite, these are all O's. It is a double salt. KCl, MgCl2 and 6H2O. So these combinations also at the times they will give. This comes under the occurrence heading for you. These are all present in the combined state. Most that form the salt originated, and they are called as the halo, means salt originated. So you can see these all points regarding the occurrence. After the occurrence, you are given with the textbook tabulated data. Very good table is given. You can see in the atomic number. We got the atomic number and general electronic configuration had given. Don't forget, this belongs to fluorine belongs to second period, chlorine belongs to third period, bromine fourth period, iodine fifth period, acetylene sixth period, and tennessine seventh period. So if you remember, this is the N, you can write the electronic configuration of the any element. For example, I am giving the electronic configuration of tennessine. What is electronic configuration of tennessine? Outer electronic configuration we can see 7s2. It is belong to which period cell? And this is our period number. This is the period number. So 7s2 7p5. 7s2 7p5. But before the 7s, in the 7th period, we will have f orbitals, right? So before the f, we will have the d, like this 60, 10 and 5f 14. And before this, we will have the noble gas. So you please remember, the outermost electronic configuration depends upon the period to which they belong to. So we have seen the electronic configuration of one of the elements. Remaining you must practice. We have the occurrence. Coming for remaining properties, like what is the next property we can give? Electronegativity. In general, these all elements are highly electronegative elements, as they need one electron to complete their octet electronic configuration, and these are highly electronegative. And the entire group will have similar properties due to this single gaining of the electron. Down the group, generally electronegativity down the group, electronegativity decreases. It is the element with the highest electronegativity, fluorine. But here comes our main point. Electron gain enthalpy. Well, how is the electron gain enthalpy given? Electron gain enthalpy is given as delta EGH. Electron gain enthalpy. So once you see the sizes or the atomic radii. Generally down the group, atomic radius will increase, we said. But the first element is fluorine. First element is fluorine. Due to its small size, see here fluorine is there, which is of very small size, and here is the chlorine. Already 7 electrons are there. Here already 7 electrons are there. If one electron need to come and join to make it to octet, these 7 electrons are very close to the nucleus. Already they are experiencing repulsion between each other. Hence, the electron cannot be added into this outermost orbital. So what we say, electron gain enthalpy of the fluorine is lesser than that of chlorine. Electron gain enthalpy of the fluorine is lesser than that of chlorine due to the small size of the fluorine. But in chlorine, as the size is more than the fluorine, it can readily accept the electron. Now coming to the bond dissociation enthalpy. So before I go to this bond dissociation enthalpy, let me give you an order about the electron gain enthalpy. So already we said chlorine is more electron gain enthalpy than fluorine. Even though fluorine is highly electronegative element, its electron gain enthalpy is lesser than the chlorine. Again, down the group, what is increasing? Electronegativity is increasing. Means their electron gain enthalpy decreases. So keep in mind here, this is a very important order. In general, fluorine electron gain enthalpy must be greater than chlorine, but due to its small size, its electron gain enthalpy is lesser than the chlorine. This is the very important order we must not forget. Coming for bond dissociation enthalpy. What is meant by bond dissociation enthalpy? It is represented with the symbol delta DIH. Dissociation enthalpy. Here fluorine is there, and the amount of energy that will supply to break the bond between the two atoms is called as the bond dissociation enthalpy. Imagine these are very small. Coming to the chlorine, these are somewhat large or more in size. Atomic radius is more as the new shells or orbitals are added. Now, bond dissociation enthalpy. Generally, what we know, electronegativity of chlorine is very high. So, it must hold the electrons very firmly. But the lone pairs on this fluorine are experiencing more repulsive forces. They are decreasing the bond dissociation enthalpy of the fluorine due to the presence of lone pairs on the fluorine. The bond dissociation enthalpy was decreased. And now the order we want about the bond dissociation enthalpy. Fluorine, or you can speak chlorine, bond dissociation enthalpy is more than bromine, which is more than fluorine, which is more than the iodine. You don't by heart the values. Remember this order. That will be very clear for you. Bromine is chlorine bond dissociation enthalpy is more than bromine. Okay. Means here the electronegativity plays, but in the case of fluorine, electronegativity does not play any role. The repulsive forces are playing the role, hence its bond dissociation enthalpy is decreasing. So keep these two in mind: electron gain enthalpy order and the bond dissociation enthalpy order. So coming to this introduction, we can introduce all these points. Coming for next with their physical properties. What is the color of fluorine? Fluorine is having yellow color. Fluorine is having greenish yellow color. Physical properties, if you see physical properties. Once you have a glance of this physical properties, children. Physical properties, if you see, fluorine is a gas and chlorine is also a gas. Bromine is a liquid. Iodine is a solid. The colors, if you see, fluorine is yellow color, Chlorine is greenish yellow color. Greenish yellow color. Bromine is red color, and iodine is violet color solid. Violet color solid. Why are they showing characteristic color means NS2NP5. In the p orbital, one electron is present in an unpaired state, that is absorbing the frequency of light of a particular frequency, and it is getting excited and getting emitted down. So due to the free electron, these are showing the characteristic color. And that's what about the physical property. Now you can go for the chemical properties. Once you start studying their chemical properties, if you start studying their chemical properties, very important table is given here, children. These are all acting as very strong oxidizing agents. These are very acting as strong oxidizing agents. Oxidizing agent. What are these nature? These are the strong oxidizing agent. Which is the strongest oxidizing agent among all? Fluorine is the strongest oxidizing agent among all the given halogens, because its reduction potential is very high. Its standard reduction potential is high. This reduction potential is high. This oxidizing property of fluorine depending upon the standard reduction potential. It does not depend upon electronegativity of fluorine. Does not depend upon electronegativity of fluorine. Very important reason is this one. From this they may ask the questions for your objective. Why fluorine is having very strongest reducing agent means its standard reduction potential is very high. It is not depending upon the electronegativity. What it can do? The halogen, whatever it may be, it can reduce the higher halogens. Halides. Halogen can reduce higher halides. Any halogen can reduce the higher halide. Means what? Fluorine, if you see, it can reduce chloride, bromide or iodide. Chloride, bromide or iodide. Into how? It is going to accept the electrons here. It is going to accept the electrons, and that is going to be converted into the particular halide. What about chlorine? Chlorine can reduce the next higher halide. What is the next higher halide? Bromide or iodide. Bromide or the iodide. And it is getting reduced. What is going to be oxidation, children? Loss of electron. No? These are making the another species to lose the electrons. So we say these are acting as a very strong oxidizing agents. And hence you can see here it is getting converted into particular halide ion, whereas the bromine can oxidize only iodine, because the halogen can reduce or oxidize the higher halides. Oxidize the higher halides. And here you can see it is converted into bromide and it is converted into iodine. And this reacts with water. Like fluorine reacts with water to form the corresponding how many hydrogens are there? 4 are there, no? 4 H plus ions it will form, and 4 F minus ions it will form. Along with that one, that will be releasing the oxygen. But coming to chlorine reacts with water to form the hydrogen halide and hypochlorous acid. So these are the reactions that will be shown with bromine also. And coming for our iodine will be showing a reverse reaction. Iodine will be showing a reverse reaction for these above said property. So in the chemical properties, these properties are very important. Now we are going for how do they will react with hydrogen. Means they will form some halides. These are all going to form some halides. What type of halides will be formed? If you see here, our fluorine reactivity with hydrogen. It reactivity with hydrogen. Reactivity with hydrogen. Or they are form the corresponding halides. Hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. Hydrogen chloride, hydrogen bromide, hydrogen iodide. Okay, children. Here, why I have written down means I just want to show hydrogen is this one and this is the fluorine. Hydrogen and the chlorine. Hydrogen and the bromine. Hydrogen and the iodine. So what we can find, as the bond length increases, stability of the hydrogen halide decreases. So thermal stability order. First you can find the thermal stability order. Thermal stability order. Which is least stable, hydrogen iodide is least stable. So what is the least stability order? Thermal stability means hydrogen fluoride is more stable than hydrogen chloride, which is more stable than hydrogen bromide, that is more stable than hydrogen iodide. Or you can write this one in an opposite method, acidic nature. Acidic nature. Acidic nature means what? The one that can readily lose the hydrogen. This is thermally unstable means it can readily lose the hydrogen. So among this one which is highly acidic means hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. The one that is readily losing the hydrogen, we can speak, it is very highly acidic in nature. So these are the very two important properties not to be forgotten. And coming with the reactions, still we can see here the reactivity towards oxygen. How do they react with the oxygen? These are forming the corresponding oxides. These are forming the corresponding oxides. Once you please have a glance in textbook, because many oxides are there. Many oxides are there. You must read with all those points one by one. In all the oxides of the halogens, the higher oxide, very simple point you must remember. When they are forming the corresponding oxides, the higher oxide, any of the what we can call halogen oxide. If you see, simple you can start like with fluorine. Fluorine can form two type of oxides, OF2 and O2F2. What are the oxides of fluorine? Oxides of fluorine are OF2 and O2F2. This is one of the important area because in this electronegativity of fluorine is -1, 4.0, oxygen is 3.5. Fluorine being very high electronegativity, it will show a -1 oxidation state, and two fluorines are there now, hence oxygen will show +2 oxidation state. And this is called as the fluoride of oxygen. This is called fluoride of oxygen. Whenever we have an element with highest electronegativity, it is considered as fluoride or the ide of the particular oxygen. In this case, what is the oxidation state of fluorine, children? Fluorine will show a -2 oxidation state. Generally, the fluorine does not try to form any +1 oxidation state, except only one of the oxidation state like HOF. In this, if you see the oxidation state, what is the oxidation state of fluorine? Here hydrogen is 1, oxygen is 2 into -2, 1 into -2. We want that of fluorine. So here 1 -2 plus x, or here -1 plus x is equal to 0. Here x is equal to +1. Only in this case only fluorine is showing +1 oxidation state. But coming for the chlorine shows many oxides, like we will see all those oxides on the board. Let me write a list of the oxides of all chlorine, bromine and iodine. Okay children, here we have our reactivity towards oxygen we had already seen what type of oxides of fluorine are formed. Again, in that one point, I would like to find out the O2F2. O2F2, this point is very important, that is taken from the oxides of fluorides of oxygen. O2F2 oxidizes plutonium to plutonium hexafluoride from the spent nuclear fuel. So plutonium is being added with an electronegative element, and that is taking place in the presence of the O2F2. As we speak, O2F2 is acting as a good oxidizing agent to oxidize the plutonium to plutonium hexafluoride. The remaining are with the chlorine. The chlorine is having many oxides like Cl2O, ClO2 or Cl2O6 or Cl2O7. Among this, we are using ClO2 as a bleaching agent. In the paper industry, we can see paper in the white color or the clothes are in the white color, because the released oxygen, nascent oxygen, is having the bleaching property or to remove the color from the particular textile or the cloth or the paper. So which is used in the bleaching industry, children? ClO2. That is also used in the water treatment plants also. Coming with oxides of bromine, it shows Br2O, BrO3, BrO2, BrO3. These are all less stable. Whereas here these are also used as a powerful oxidizing agents. They are also used as a powerful oxidizing agents. Coming for the oxides of iodine, it forms I2O4, I2O6, I2O7, even I2O5, which is a very strong oxidizing agent that is used in the estimation of carbon monoxide. Used in the estimation of the carbon monoxide. How means the I2, when I2O5, when reacted with the carbon monoxide, that itself is forming I2 plus carbon dioxide. It's forming carbon dioxide. 5 moles we can take. So 5 moles of carbon dioxide are formed. So here we will first identify how much amount of iodine is liberated in the volumetric analysis. So by that we can identify how much of carbon monoxide is consumed in the reaction. So volumetric analysis we will use this I2. It's not that due to it is high, it is showing some +7 oxidation state. Not that it's showing some +7 oxidation state. What is the oxidation state there of I2O5? Calculate the oxidation state of each element in their oxidation states. Don't forget one statement. What the statement I had written here is, whatever oxidation state is higher the oxidation state, higher the oxidation state. When the higher the oxidation state, the oxide will be more acidic in nature. We brought this point in the D block and in the F block also. When the oxidation state increases, acidic nature of the oxide will increase. Now coming for our iodine, its reaction with oxygen, you can see higher stability of oxides of iodine. Are due to get greater polarizability of bond between iodine and oxygen. Polarizability means we got this one in the states of matter in the first year. So why iodine oxides are more stable means only due to the polarizability of the bond between iodine and oxygen. So simple points I had covered here from the textbook, so you can follow up these points. After these oxides of or the particular halogens, we are having the concept called how do they react with metals. Reactivity with metals. Coming with the reactivity with the metals, any magnesium, you can take magnesium reacts with bromine to form the magnesium bromide. 1 minute children, it went off. Let me rearrange. Yeah, magnesium combines with bromine to form magnesium bromide. Similarly, many metals will form. Tin will combine with chlorine to form tin tetrachloride, or it will form tin dichloride. In case of metal halides, the metal with higher oxidation state, will be having more covalent nature. nature. Previously what we had seen, higher oxidation state of non-metallic halide. Non-metallic halide. Non-metallic halide will be acidic in nature. Will be acidic in nature. Here what we are speaking, metal, when it is present in two different oxidation states, metal in the higher oxidation state will be having more covalent in nature. Then after this we can see their interhalogen compounds, XX-1, XX-3, XX-5 and XX-7. So let us see the interhalogen compounds also here. Interhalogen compounds. If you see the interhalogen compounds, what type of interhalogen compounds are found, children, there? We can see chlorine. Textbook equations only you practice. Interhalogen compounds. Interhalogen compounds. See, interhalogen compounds are of many types: XX-3, XX-5 and the XX-7. What is the shape of this XX-3? XX-3 will have the bent T shape. XX- will have the bent T shape. Let me give you some preparations, then we can go. Chlorine reacts with fluorine of equal volume to give ClF. The similar chlorine also will react with excess of fluorine to form chlorine trifluoride. The chlorine reacts with bromine to form chlorine tribromide. The chlorine reacts with bromine in excess to form chlorine pentabromide. Similarly, the reaction with iodine also you can see. Iodine reacts with chlorine to form iodine chloride, or iodine reacts with chlorine to form iodine trichloride. These are the preparations of the interhalogen compounds. So here, once we got the ClF3 or CrB3, central atom will be chlorine, and here 3 bromines we must express. But here, due to the presence of lone pair, these halogens will be little bended. The halogens will be little bended from their actual position. They will be bending little from their actual position. Hence, what we will be getting? T shape or bent T shape. Coming for XX-5, any of the interhalogen compound you can take. There you can see central atom chlorine, if it is there, ClBr. 5 means here 5 bromines will be present, and there will be one lone pair. So it is a square pyramidal. Here pyramidal is coming below. So we can give the shape of the molecule as square pyramidal. But coming for IF7, this is the only compound being formed here. It is called a pentagonal bipyramidal. So these preparations and shapes you must not forget, children. Coming for the next compound, we have about the chlorine. About the chlorine, I will not give all equations. Some equations are very important for NEET and JEE mains. Only those equations we will see. What are the equations we can have of chlorine? What are the preparations of this chlorine, children? MnO2 combines with 4 moles of HCl to form MnCl2. MnCl2 plus 2H2O and chlorine gas is liberated. In this we must heat them. You can also substitute in the place of HCl 4 moles of sodium chloride, and you can take 4 moles of sulfuric acid. In this case, what is being formed means, you can see manganese dichloride is being formed. 4 moles of sodium hydrogen sulfate is formed. Water, how many are there? 2 moles of water is being formed, and the chlorine gas is being evolved. In these two cases also, what we must do? We must heat But there is one question from NEET. How is chlorine gas prepared at room condition? At the room condition. At the room condition means you will react manganese dioxide with 16 moles, potassium permanganate. What you are using, children? Potassium permanganate. You are reacting with 16 moles of HCl. This is taking place at room temperature. Means you are not heating anything. You are not heating anything. Then what are the products formed? 2 KCl plus 2 moles of MnCl2 you got. And 16 hydrogens are there now. You need to send out in the form of 8 Cl2 and remaining chlorines. You please balance. I am not balancing here. You please balance the remaining chlorines. How many will be there? Here 8 are there. Here 4 are there. Here 2, 6 are there. Means out of 16 chlorine 6 are there. Remaining 5 are there now. 5 Cl2 will be getting. And the next important is manufacturing is called as Deconst process. What is Deconst process? What is Deconst process, children? You are going to heat hydrochloric acid. You are going to heat hydrochloric acid in the presence of CuCl2 catalyst. In the presence of the CuCl2 catalyst. Once have a glance over this reactions of the chlorine. Also how it reacts with the metals, non-metals, and the further uses also. At last we have the uses. And now after this chlorine, what do you have? Hydrochloric acid. See, every reaction I will not write on board. You please practice reactions of the hydrochloric acid. 3 moles of hydrochloric acid and 1 mole of nitric acid, what we call aqua regia, that will melt even gold or platinum. Good. And next is the important concept about oxoacids of halogens. What is the concept about regarding the oxoacids of these halogens? According to the textbook, very simple topic is given. Hypohalous acid, halic acid, and the perhalic acid. It is the topic given according to the textbook. Only fluorine will form only one HOF. Only hypohalous will form only one oxoacid is formed, but it is not forming the remaining. But our chlorine will form all the 4. HOCl. What is the structure of this HOCl? The structures are useful for only for PUC. HOClO, HOClO2, HOClO3. But how you must write is, you must write this one as HOCl, HOClO2. You must write this one as HClO2, HClO3 and HClO4. When you are writing, you will be given in that method. So in this, what are the oxidation states of this central metal, central atom? Here +1 you can see, like +1 you can see, +3, +5, +7. So the central atom will show the particular oxidation states like +1, +3, +5 and the +7. Already we had raised one point. What the point we had raised? Higher the oxidation state. These are all non-metals. Higher oxidation state of the oxide of halogen, that will be more acidic. This point you must not forget, children. Then after there is whatever concept is there, once we have a glance, but we need to do some bits from the textbook. I will upload the bits from the textbook in the most probably now itself we can do for some bits. I will upload some bits in the group. Yeah, we have the questions here, children. This time I would like to introduce about assertion and reasoning type questions. We are not doing about them in the remaining concepts, because wherever storytelling is there, there will be question there much. What is this assertion and reasoning type question? Assertion means they will give one statement. We must find out, is it the statement or true or false. How can we find? Means below one reasoning will be there. And short noted assertion as A. Reasoning means this is going to explain about A. Means it is explanation about the statement A. Whenever the assertion is true and the reasoning is also true and the reasoning is the correct explanation for A, you will be opting option A. When the assertion is true, and the reasoning is also true, but reasoning is not the correct explanation for assertion. Then you must go for the option number B. If assertion is true but reasoning is false, then you will opt for the option number C. If both assertion and reasoning are false, you will opt for the option D. So this type of questions, one question we will be starting from the question number 1. I2O5 is used to detect carbon monoxide. This question is given in the AIMS 2019. I2O5 is used to detect the carbon monoxide. Yes, that's a true statement. Everyone knows. We got the oxides of iodine. In I2O5, oxidation state of iodine is +5. Yeah, correct. That is also you can see I2O5 2x plus 5 into minus 2 is equal to 0, or 2x minus 5 minus 10 is equal to 0, or x minus 10 upon 2 is equal to 0, or you can see this goes with 5, x minus 5 is equal to 0, x is equal to +5. It's a +5 oxidation state. The reasoning is correct, but it is not explaining anything regarding the estimation of carbon monoxide. We learned the point. In this, the iodine that is liberated, it is used in the volumetric analysis to estimate back the amount of carbon monoxide reacted. See now what happened? Assertion is true. Reasoning is also true. But reasoning is not explaining the assertion. At the time, what type of option you must take? You must take the option B. Once you review the topic that was taught today, then go for not true for the halogens. You must find out which is not true for the halogens. All forms monobasic oxoacids. What is meant by this monobasic oxoacids? If you see HOF, if you see HOCl, if you see HOBr and HOI, these are all oxoacids, or we can say hypohalous acids. They are ready to give one H plus ion and the OF minus ion. Is it not? So we said the ability of this oxoacid to lose one hydrogen is said as monobasic oxoacid. If they are readily giving one hydrogen, it is called as a monobasic oxoacid. All the halogens will form the monobasic oxoacids. Is it not? So that's what the first statement given. That's a true statement. We must find not a true. All are oxidizing agents. Yes, we already studied this statement. These are all strong oxidizing agents. All but fluorine show +1 oxidation state. Here OS means I have shown as oxidation state. All but fluorine shows +1 oxidation state. See children, what are the oxidation states of this group 17 elements? Oxidation states of this group 17 elements are -1, +1, +3, +5 and the +7. The oxidation states of this group 17 elements. What is the statement saying? All but fluorine show +1 oxidation state. Here it is saying all are showing +1 oxidation state except fluorine. Is not fluorine showing any +1 oxidation state? Fluorine is also showing +1 oxidation state. In which case HOF. In the HOF we already calculated. Fluorine is also showing the +1 oxidation state. That is the only component is showing. So we can go. This is not a true statement. Actually, what statement is given? All are showing +1 oxidation state, but fluorine is not showing +1 oxidation state. But still, fluorine is showing +1 oxidation state in which oxoacid HOF. Coming for question number 3. Assertion: fluorine and chlorine, when passed through water, F2 is more reactive. We had already seen the reaction of fluorine and chlorine with water. Fluorine is giving out the oxygen, chlorine is forming HCl and HOCl. Here, what is the reason is saying? F2 is more electronegative, and I raised one point there. The reactivity of this halogen is due to its standard electrode potential, not due to electronegativity. Its standard electrode potential is more. When the standard electrode potential is more, it can be hydrated easily. Enthalpy of hydrogen also will be more. So it is related not to its electronegativity, it is related to the standard hydrogen, standard electrode potential. So what is the reasoning saying? Reasoning is not explaining the assertion. We know fluorine is more electronegative, but reasoning is not giving explanation for assertion. What is the explanation for assertion? Here fluorine is more reactive due to only the standard electrode potential. When assertion is true and reasoning is also true, but reasoning does not explain A, we can give A or B. We can give the B. Coming for fourth one. Assertion. O2F2 converts plutonium to plutonium hexafluoride. Very good. Reasoning. O2F2 is used to remove unreacted plutonium from spent nuclear reactor, we can say, or nuclear reaction. Good. So this reasoning is giving correct explanation for A. Hence the unreacted plutonium is converted into plutonium hexafluoride. When reasoning explains A and both the assertion and reasoning are true, we can go for the option A. I hope you are able to do this type of questions, children. Assertion and reasoning. See here we got few more questions, children. Fifth question. Which halogen has highest value of negative electron gain enthalpy? Generally whenever electron is being added, the electron gain enthalpy will be in a negative value only. Which element is having more electronegativity? Fluorine. But the lone pairs which are very close on the fluorine, they are not letting the electron to be gained, but it is done in case of the chlorine. So chlorine is having more negative electron gain enthalpy. You can blindly go for the option. Correct order of bond dissociation enthalpy. Some order is given: bromine greater than iodine, which is greater than fluorine, which is greater than chlorine. Fluorine greater than chlorine is greater than bromine, is greater than iodine. Iodine greater than bromine, which is greater than chlorine, which is greater than fluorine. Chlorine greater than bromine, greater than fluorine, greater than iodine. I had already explained this point, bond dissociation enthalpy. So you find out which is the correct. Here bond dissociation enthalpy of fluorine is lesser than the chlorine. Okay. In this case, we can find two options. Fluorine bond dissociation enthalpy is lesser than the chlorine. Here you find they are saying fluorine bond dissociation enthalpy is more than the chlorine. That's the wrong statement. Here also you can find fluorine bond dissociation enthalpy is greater than chlorine. That is also false. Chlorine is having more bond dissociation enthalpy than fluorine, or fluorine is having lesser than chlorine. So coming to this, we can study like chlorine is greater than fluorine, but we are having one more order: chlorine greater than bromine, which is greater than fluorine, that is greater than iodine. Generally what children will blindly see is, sir, you said fluorine is less than chlorine, no, so can you put all? No. In the textbook, the equations that are, values that are given are, chlorine is greater than fluorine is said. Again, the chlorine value is more than bromine, bromine value is more than iodine, the least is with the iodine. So this is what the correct order. In this case also, fluorine is lesser than chlorine, but between them, bromine is there. Don't give up this type of orders of bond dissociation enthalpy. Coming for boiling point of HF, HCl, HBr, HI are in the order of. This is according to textbook only I had given. Once you go through the textbook tabulated data. Boiling point of HF, HCl, HBr, HIR. How about boiling point, children? Whenever atomic mass is increasing, boiling point will increase. Hydrogen is the same in all these cases. So what we say? Fluorine, chlorine, bromine and iodine. When atomic number increases, atomic mass will increase. Which is having highest atomic number here? Iodine. So obviously everyone will go for the point. How? From here to here, from here to here. What is increasing now? Atomic number is increasing. Whose atomic number is increasing? Halogen atomic number is increasing. By that, atomic mass will increase. So what we expect generally? Fluorine boiling point will be lesser than chlorine, which is lesser than bromine, which is lesser than hydrogen iodide. Means hydrogen iodide mass is more and its boiling point will be more. This is the order that we expect. But the point comes here. Fluorine being highly electronegative in nature. Highly electronegative in nature. It forms very strong hydrogen bonding. Very strong hydrogen bonding. Hence its boiling point is more than all the hydrogen halides. Then all the hydrogen halides means hydrogen chloride is having lesser boiling point than hydrogen bromide, which is having that hydrogen iodide. The top comes the hydrogen fluoride. Among all hydrogen halides, it is having highest boiling point only due to high electronegativity, which forms the very strong hydrogen bonding. So, which will be your answer, children? Keep in mind, when the halogen mass is increasing, boiling point will increase. But prior to among hydrogen fluoride is forming hydrogen bonding. Hence, it is having very strong or more boiling point than remaining all hydrogen halides. From this, what statement will you find? Which is the correct option? Is the correct option, children? Can you put say here? Hydrogen fluoride is having more than hydrogen iodide. More than hydrogen iodide. So this is the option number B. Remaining I will upload in the group. You please check them. Thank you. Or tomorrow in the next class I will continue the remaining with the group 18.